Welcome to Sigma Solver, guys. Today we are going to look at a crucial architectural setup using Google Cloud, which is SQL Server setup, or any SQL server, in this case like Postgres, MySQL, and how we connect it to backend and in a suitable architectural way. Right. So this is going to be a hands-on tutorial, so all the steps will be provided and we can follow them along to get the experience of how we can set up SQL Server on the cloud as well as a backend connected to it. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. So first we are going to look at Cloud SQL setup. So let's get into the steps. So starting out, we'll see something about the billing structure first, because that is what you will be presented at the start. Is so when you are in a new project like I have right now, so you'll probably get the free trial for 90 days about for $300 US, right, which sums up to be around 26,163 credits. So this you can use for testing out purposes, as I am doing right now, and based off that we can test out how different optimization strategies for cloud resources can help us reduce costs later on, right? And if I just tell you about their billing structure, so we'll see that together. Is they have for India, as you can say, is they have credit cards, debit cards, as well as UPI autopay. So you can set up a particular amount, which is 15,000 right now, as the upper limit for each month what they can deduct from your account. And once that is set up, you don't need to give any card details as well, right? So just give your UPI ID, and once that mandate is allowed, you will be good to go. All right. So before we jump into anything, what I'll go is, so this is your billing dashboard, of course, and first we want to start up a SQL server, right? So right now you see that I have one particular PostgreSQL server running, right? What I'll do is create one another. So the first one is the very famous MySQL. So it's towards more of open source RDBMS, and it's very heavily used by organizations. So mostly web applications, small to medium sized applications, can run very well on this one, and it is also very cost effective, right? So that is one thing, but it has a few less advanced features than Postgres. Then we come to the PostgreSQL. So if your application requires complex queries that need to be run or needs to maintain high standards or compliance with different governments, so then we can use this. Also for warehousing and analytics, Postgres is better. Of course, as I am saying it, that Postgres needs more handling or a bit more complex than MySQL, so the learning curve can be steeper. Then we come to the SQL Server. It is kind of proprietary RDBMS developed by Microsoft, and it is tightly integrated with Windows architecture and offers advanced features for enterprise that target the Windows ecosystem, right? So CRM, ERP, those of stuffs can be integrated with SQL Server well. So lastly we come to the AlloyDB for Postgres. So this you can say is a fully managed solution which is Postgres compatible, and it is kind of offered by Google Cloud in itself. And as you can say that since more of the optimizations are being done from Google automatically, so it is kind of on the more pricier side. So for this tutorial we will be using PostgreSQL, so let's choose that. Now I'll be moving you through the different options that we have here and their meaning, as well as what we can do in order to optimize the costs starting out, right? So if you are coming from a different background, and you have an established SQL server and need to optimize it, still this tutorial will help you. Or even if you are starting out and a bit confused regarding the pricing, then also it will help. So first comes the Enterprise Plus and Enterprise. So it says a Cloud SQL edition determines the foundational characteristics of your instance. Choose the best option for your price and performance needs. So Enterprise Plus is something that is used by large organizations or a bit medium sized to large organization scale businesses, and it is, as you can read from here, is more dedicated to your data and has more fault tolerance capabilities towards that architecture. Then if we come to the enterprise part, it has a slight less SLA specification, and the sub-second planned maintenance downtime is also a bit higher, right? So those things matter for a large scale business because there are multiple or a lot of customers they need to tackle on. So Enterprise Plus is for them. But if you are someone who is just starting out, trying to figure out different versions, and you are more on the cost effectiveness side, so I think Enterprise will do the job. Then we come to the preset for this edition, and again there will be multiple fields which we need to assign later on, and we'll go through them by the fact that which can be edited later on and which cannot be. So as we can see that this can be edited later on as well. So we see that production has the highest virtual CPU cores, RAM as well as storage. So it's highly available. Then comes the development. So it's slightly less. Development is more for the projects which are towards the launch, right? And like they are halfway the development, or mostly the development is done now, only staging and testing is remaining. So for them development is good, but for just starting out, I'll say sandbox will do the job, right? Because we'll get ample amount of virtual CPU as well as RAM to test out database operations and consistency checking. Then the database version, right now at the time of recording this video, it's PostgreSQL 17, the latest version, and PostgreSQL 16 is the stable version. So I'll choose PostgreSQL 16. Now instance ID is something that you can customize. So I'll just tell or give it a bit short, right? And you can generate the password, or we'll keep it simpler also, right? Then we'll need to choose a password policies is also one thing which you can impose, but I'll not recommend it for initial stages. But later on you can set up a policy to impose the requirements of what the users will have to do in order to authenticate local users, right? Next we come to the region and zonal availability. So for better performance, keep your data close to the services that need it. So let's say that your app runs primarily in India, so it's better to put your SQL server in a region close to India or in India. So right now I am seeing Mumbai and Delhi, so I'll choose Delhi, right? Then it comes single zone or multiple zones. So as the name suggests, if it is multiple zone, so the cost will be a bit higher, and what it will allow is basically for high availability. So let's say the business which is using this particular service is located in multiple places, so maybe Singapore, Malaysia and other regions as well. So for them it is highly required that the data is available throughout these regions, right? And it is distributed across multiple zones. So it may happen that the SQL server running in Delhi goes down for some reason. So we don't want that to be experienced by our customers. That's why we choose multiple zones, so that SQL server running at a different zone can come to rescue at that point and handle the request at that point. Later on, when this becomes available, again the normal SQL server runs as it is, right? But for starting out, again, we don't have any customers right now, so then single zone will do the job. We can more specify about which zone are we targeting, as it is Asia South to A, B and C, so we can choose that as well. Next, we go to the customize your instance. So first one is machine configuration. So machine configuration primarily determines what sort of machine, let's say compute engine or the underlying infrastructure which will be used by the SQL server to be run upon, right? First we get to this point, which is shared core and dedicated core. So dedicated core is something where the hardware resources is primarily or solely allocated to the SQL server that you are deploying right now, right? That is called dedicated core. And shared core is like having a pool of hardware and your SQL server is just using that hardware when it needs to do that, right? That's why it is shared core. So as the name suggests, that shared core will take less resources, will be on the less expensive side. So we'll choose that. Similarly, we can choose it based upon the requirement as it is given here. Your selection has enough memory to hold your largest table. So let's say you run a particular query and it requires the entire table on which the query is run to be loaded into the memory. So this particular memory which is shown here should be able to take that, right? Again, starting out, this will do the job, but later on when we have more customers and more data to be queried upon, then we'll have to change this to dedicated core as well as increase this usage as well, right? Okay. Next we come to the storage. So now this choice is permanent, right? Either we choose SSD or HDD, we cannot change the data. So SSD is the most popular choice. Why? Because of low latency, of course, and we know it on our computer systems as well that SSD is more faster than HDD. So we can make the choice accordingly. But again, this has slight chance to do with the pricing stuff, but still SSD will be a bit pricier than HDD. So we'll go with HDD for now. Next we come to the storage capacity. This section is editable, right? But the only catch here is the capacity can't be decreased later. So let's say I put 10 GB now and later on I decide to increase it. So once I go to 20 GB, I cannot reduce it back to 10 GB, right? Even if I delete the data from the SQL server tables, still I'll not be able to reduce it to 10 GB. Then there is one another section which is enable automatic storage increase. So if this is enabled, then whenever we are going towards the capacity of the SQL server storage that we allocated, we are going to have an increase to the next tier, right? So let's suppose, for example, if your SQL server is allocated initially 10 GB and you are spiking up to 9.8 for the first time, then Google Cloud will understand that it is almost toward the limit and we can now change this to 20 GB instead of 10 GB, right? So that's how it works. Next, connection. Now here is what we'll need to pay attention. So here, choose how you want your source to connect to this instance, then define which networks are authorized to connect. So since we are creating a SQL server, we'll want some backend or some other software service to get connected to this for data operations, right? So there are two options. Either we can go for private IP or public IP. So private IP assigns an internal Google hosted virtual private cloud IP address and requires additional APIs and permissions, and it can't be disabled once it is enabled, right? So I'll come to this later on. First, let's discuss the public IP. So this assigns an external internet accessible IP address, requires an authorized network or Cloud SQL proxy to connect to this instance. So if you do this, you will be able to connect from your local backend, right? It will give you an IP, you can straight away connect to it, do the operations, perfectly goes well. But if you want to connect it to your existing or deployed backend, then this won't work directly. You will have to set up the Cloud SQL proxy and connect it that way. But still, if anyone tries to get access to your public IP, and if suppose he finds it, so he'll be able to connect to that, given the database credentials are also there, right? So we'll not go for this one because it requires additional security and more overhead for database management as well. So we'll go for private IP, and what we need to do here is set up this private service access settings. So here you can determine a particular network on which this particular connection will be hosted. So right now it is the default, but if we go here, then we'll be able to land into the VPC network page, and here we can basically create a particular VPC network. So let's say I create test net. So now this particular VPC network is custom built inside Google Cloud for that particular database, and it can be used by all the software services that we connect to that database, right? Now then you can set up the different configuration settings inside this particular dialog box and go with that, right? But I have already created a particular default network previously, so I'll be using that only. So if we go here, we see that we have chosen default, which is one of the VPC networks GCP already provides you with, right? So we can choose that, and then basically we'll have to return back to this particular part when we connect our backend to the SQL server. Then we come to the data protection part. So the first portion of this one is automatic daily backups. So if we want our data in the SQL server to be backed up daily into a separate storage, so if I go here, so we'll see that this particular section is for the backups, and backups you can say are the screenshots of the SQL server at different time instances. So automatic daily backups is the option where you can enable it to get daily backups, and those will be again stored in the same SQL server database itself, right? And the number of days denotes the number of days for which you need to maintain the logs of the backup, right? And backup window is the time when the backup should be done by the GCP. And enable point in time recovery is something that if let's suppose we had a fault on 22nd March 2025 around 8 AM, then I want to get the recovery of the database at 22nd March 7 AM, right? So if you want that, then you can enable this as well. So again, we have to maintain the logs for this recovery. So you can set how many days of logs you need to retain in order to perform this particular recovery operation. And again, all these options will add up on the costs, although they provide excellent data fault tolerance. But this is something that we should consider when we have a lot of data or crucial data to be taken care of, right? So right now I'll just disable it. This is something that you should always keep on, is prevent instance deletion. So if suppose on your IT team someone by mistake tries to delete the instance, it will not happen until they have the permission to come here, which is the edit page of course, and then uncheck this, right? So this was for connections and data protection. Now we go for the maintenance. So maintenance is typically for the SQL server regarding any crashes or any system failures. So they will be done by GCP, and we can change the frequency of their operation as well, right? I'll keep it the same for now, but you can change it accordingly. Next, we have flags and parameters. So This is something that is more towards LLM training and how you want your data to be granular and be sent to your training models for processing or online prediction. Next is query insights. So it is basically towards the query understanding of how the queries are being executed, and if they are not being able to execute fast enough. So those insights are basically gathered in this particular section. Lastly is the labels. So you can use labels to basically organize your Cloud SQL instances. If suppose you have multiple Cloud SQL instances, then you can choose to have a label for them. So that was all for this one. And as we were changing this settings, you might be also noticing that the summary was changed as well, and you can get a sense of what the price will look like after all the settings being done, right? We have the network throughput, IOPS, number of read write operations, and so on. So I'm good with the settings that I have made here, and I'll go and create the SQL instance. So now this will take around 12 minutes. So let's go back and see what are the next steps. So as you can see that it is being created. Now we are completed with the first part of the tutorial, which was Cloud SQL setup. Next we'll come to the Node.js backend setup. Now this particular instance we are using Node.js, but the architecture will be very similar for all the backends that are available, be it Django or Spring Boot or any other backend as well. So we will be starting with an existing Node.js backend that I already have created, and see how the connections proceed as we start deploying it into Cloud Run. So we are again back at our Google Cloud Console, and as we can see it is still working to create the Cloud SQL instance. We'll go to Cloud Run and we'll deploy a container as service or job. But now we'll notice that we already have that particular repository in GitHub. So if we have a repository in GitHub, then it is quite easier to connect that directly. Otherwise, if suppose you have it on Bitbucket, you will have to do different set of steps in order to deploy it to Cloud Run. I have previously made a video regarding how you can deploy your code from Bitbucket to Google Cloud. You can check out that video here, right? So now let's connect our repository. And we'll set it up with Google Cloud. So we see that we have this is the one, and we'll try to deploy it. For right now we want this particular main branch, but we can have different branches as well, or we can have it on any branch also. So whenever a commit gets pushed onto the GitHub, it starts building it and deploying it. Next, we'll also need a Docker file for this instance. I'll rather suggest not go with the Google Cloud's build packs because it makes a bit complicated. Rather, you can define your own Docker file for simpler applications and proceed with that. Okay, so we have that particular thing set up, and what we will do again, now this thing is more towards where are your users located. So I want this particular Cloud Run service to tackle the users in India. So I'll go and choose India in the settings, right? Then comes the part where do we want to allow authenticated or unauthenticated users invocations. So right now I'll choose unauthenticated, but later on if we want, we can make it to have access only via Cloud IAM permissions level, which is actually going to be beneficial if we have the cloud service account integrated on the front end and basically using that particular service account key to access this backend URL. Billing should be always request based, because then it will help to reduce the costs further. Instance based billing is beneficial if we want the entire CPU to be utilized for the Cloud Run instance, and we should always select auto scaling because it allows Google to understand the traffic and increase the number of instances accordingly. So all those settings are done. Now these settings will be done in the next section of the video, and we'll create the instance right now. And we know that it will not run because the code already has a portion which tries to connect to the database. So we'll try to create it. Right. So this actually creates the instance from the code, builds it, and as you can see, it is trying to deploy the from the repository itself. Right. It saves us the extra steps of manually doing the build trigger as well as the artifact registry, which we have seen in a previous video. So we are trying to see if this particular backend function runs or not. It will take some time. As we can see that the Cloud Run instance didn't successfully connect, and we also get the message that database connection error, that the connection refused basically, right? So now what we want to do is go to the next step in the video where we start the connection part. So in this portion of the video, what we will be doing is connect the components of Cloud SQL as well as the Node.js backend that we have just deployed. So the first step in this one is going to be adding a user in the database first, and then using their credential to log in via the deployed container that we have seen just now, right? And once that is established, we'll be able to get the message of database connection successful and use the particular role level for which the user has defined or created the database instance. So now from here we'll go to this particular section, go to our instances, and we can see that we have successfully created our instance in Cloud SQL. And what we want to do is go to users, and there we want to add a user. So let's say I put it yt inst, and I need to save it. So what I'll do is I'll open up a new tab, put it here, and generate a password, also put it here, right? And one more thing which you can notice here is we can use the built-in authentication. So it creates a username and password specific to this instance, and user account will have the super SQL user privileges, basically the root access, and you can customize it later on as we need, right? But if we use Cloud IAM, then we can use an existing principal in the instance. So it can be a service account, it can be a group. Basically group is the best if we use here, because then we'll allow a set of users or the entire IT support team to get access to this Cloud SQL instance, right? But for now we'll use built-in authentication and add this to the collection, right? Next we go to the connections and see everything is there well. Now here what we want to store is the internal IP address which we'll require. So I'll use another tab and paste it there, right? So this is something that we want. Also in the networking we can see that we have default network as we had made previously, right? Next what we want to do is go back to our Cloud Run instance. So now we'll click on edit and deploy new revision on the same Cloud Run instance that failed, and go to the variable and secret and use these db_user and put the name or username that we had created previously, right. Then we go to the next one, which is DB host. Now this part is very important. This place we need to put the private IP address of the SQL Server instance that we created previously, right. Next we'll go for the DB name. So the DB name in our instance will be Postgres. You can create a separate database and put that as well, but initially for connection you always need to use Postgres. What I'll suggest is better put Postgres always and use databases for the queries or the creation service layer logic inside your backend. That will be better in this case. Use that. Next, what we want to do, we want to put the DB password. Now it is this particular thing, right. Next, DB port. So if we check here, the port is going to be 5432. Next, we also want to have JWT secret. Basically, how I am determining these is from the backend that I have created. So we'll have a look at that as well, right. For generating JWT secret, what you can do is open up a terminal and use this command, open SSL rand base 64 32-bit. What it does is basically creates a 32-byte 256-bit random string and encodes it in base 64, right. So I'll just copy this and paste it here, right. So this is now done, and then what we want to do is go to the networking tab. Now before I come here, I also want to do one more thing, which is the VPC serverless access connector. Now that what it will do is we'll again go to the VPC network section, and inside that we need to create a connector. So as you can see, I have created a connector, and let's try to edit it so that I can explain you the different settings here. So it is deployed right now, and we need to choose the region as the same where the network is, the VPC network and the Cloud SQL instance. So it's better to have them all together in order to avoid any network glitch, right. So we need to choose the minimum instance and maximum number of instances that will be provisioned or connecting to each other over the network using this connector, right, and the instance type. So now instance type is very important because F1 micro instance is kind of the smallest instances or hardware instances that we have right now. If we go for E2 micro, it is a bit more for large systems, maybe 16 gigs or 24 gigs of RAM and 8 to 10 virtual CPUs like that, and E2 standard is completely for like large systems, right. So that's how you can create a connector, and as you can see that I have right now 2 instances, and it will slowly come to 4 when we have this connection as well, right? So we go to this particular section which was for networking, connect it to VPC outbound traffic, choose the network and subnet. Subnet was also, if we go back and see in the VPC network, subnet is also was default, right? Default subnet needs to be put in place. Next, then we route the requests that require private IPs to this VPC, and we serve this revision immediately. Right, so it is again deploying. So you can check the logs from this section as well. So as we can see that it was able to deploy it, and we are getting database connection successful, available tables in database. Right now we don't have a table, so we cannot see that, but we can, what we can do instead is go to Cloud Shell, or rather go that here, authorize it. So what we will do is basically try to connect the Cloud SQL from here and try to create a table so that we can check it out on the Cloud Run instance as well. So we'll use this command. So gcloud SQL connect, and the instance name, which is ytinst -- user equal to, now our user is also ytinst, and the database equals Postgres, right? So we see that we are allowing our IP for incoming connection. So this is not able to connect to the SQL server because of the private IP setup that we have done. It will be able to access it if we had made it as public IP. So what I can do is basically import some data from cloud storage and try to see if we are able to get that. Right, and table, we don't have any. Table. So since we didn't have a particular table, so it was not able to create that, and now what we'll do is try to take the SQL file for this one and try to create the same table again. So let's see if that works. So it was able to do that, and now what we can do is go back to the logs and then redeploy it again. So in that way we'll be able to see if any new data comes up. So as we can see that now dummy data is available, right, in the database. So one more thing that we'll also see today is how this particular architecture is allowing us. So now let's go to the backend and see what data is behind this particular server.js file. So what I'll do is I'll go to server.js, and once we arrive here, we see that we test the DB connection based off this particular pool that I have created. So there are user, host, database and port. So all these details we need to give, and then we need to test it out based upon this particular query, table query, right? We customize it and then we just put the table name here. Otherwise we put database correction error as previously. So that was the code. So yeah, that was the code part of this one, and we can see that it is working. Now what we will do is try to understand the costs involved in this particular architecture and how we are optimizing it. So let's go to cloud overview, and right, so slide to note that we can use the group by SKU instead of date and service, right? It allows us to the cost per date. So on 16th March I had first initiated the cloud SQL. Now this particular cost is for initializing it on enterprise plus level with the default settings, right? So if we use default settings, then this is the price that we are going to hit. And on 17th March the cloud SQL instances were halted. What do I mean by that is I had stopped the cloud SQL instance on that day. Still the bill was this much, right? And on 18th March I made the change to this particular architecture. So it was 423. On 19th March it was again stopped after changing the architecture. So it was down to 29. Now you can see like we have it split into multiple things like compute engine, networking and SQL, but still the combined cost is very less, right? If you optimize it according to the settings I have just prescribed, then the cost will be much less. So this is something that we should keep in mind, and based off the amount of users that we get, we can increase the capacity of the SQL server accordingly. That was how you can start up a SQL server in Postgres or even any other MySQL architecture and use it for your database operations, right, in Google Cloud Console. I also showed you how to connect it to a backend in order for that complete integration. If you still have any doubts or any questions, then feel free to reach out in the comment section below. You can also reach out to me in my Twitter handle. So that's been it. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.